Okay, so still in chapter 7, permutation and combination. So this is the second part B, permutation of R object from n different object. So we're going to choose a few from n different object. Okay, so how many two-letter words can be formed using the letter A, B, and C? So the first method, we can try to list down all possible answer. So you can have A, B, we can have A, C, start with B, B, A, B, C, or you can have C, A, C, B. So altogether, the total is equal to 6. Okay, so since we simply need to choose 2 out of 3, so we cannot use 3 factorial, but we can actually use 3p2. So what do we mean over here is out of 3, we are going to arrange 2. 3p2. So if you use your calculator, you should be able to see that 3p2 is actually equal to 6. Okay, so the third method, you can actually have your box ready. So the first box, second box. So for the first box, we actually have 3 choices. We can either use A, B, or C. So 3 over here. For the second box, once we choose 1 to be in front, we are left with another 2. So it will become 3 multiplied with 2, which is simply equal to 6. Okay, so the first method, this is quite easy if you simply have 3 things. But if you have more than 3, this one can be quite hard. Therefore, most of the time, I'm either using the second one or the third one. So as usual, the second one is for a very straightforward questions. That means out of 3, I simply going to arrange 2. Out of 7, simply arranging 4. For the third method, I normally use the box if I have a condition where I need to restrict the first or the last box. So that is when I use the third one. Okay, so in how many ways can a president, a treasurer, and a secretary be chosen among 7 candidates? So out of 7, we simply want to arrange 1, 2, and 3 people. So we can use 7p3. So the answer for 7p3 is 210. So if you don't want to use 7p3, you can do 3 box. And then since we have 7 candidates, so we have 7 choices for the president. And once we already choose one person to become the president, we only left with another 6 choices for the treasurer. And since one of them has become the president, one of them has become the treasurer, then only 5 other choices to become the secretary. So that means the number of ways will become 7 times 6 times 5, which is also 210 ways. Okay, so now from the digit 1, 2, 3, 4, and 5, how many 4-digit numbers will be even? So I have a condition. I prefer to use the box. So 4-digit number, prepare the 4 box, 1, 2, 3, and 4. I need to have an even number. So that means I should restrict the last digit to become an even number. So either 2 or 4 will be at the end. So there is no 0 over here, so I don't have to put any restriction for the number in front. So there is only one restriction here, where the end should be either 2 or 4. So I have 2 choices here. So out of 5, either 2 or 4 will be at the end. So that means I will be left with another 4 digit. So another 4 digit in front, and then 3, and then 2. So that means the number of ways will be 4 times 3 times 2 times 2, which is simply equal to 48. So this is equal to 48 ways. Okay, so from the digit 1, 2, 3, 4, and 5 again, how many 4-digit number greater than 3000? So 4 digit, prepare for 4 box. So you're going to prepare for 4 box. The number should be greater than 3000. I should restrict the first digit. So the first digit should either be 3, 4, and 5. So I have 3 choices for the first digit. So now out of 3, 4, and 5, one of them will be in front. So that means I'll be left with 1, 2, and another 2 digit from here. So that means 4 digit, 3, and 2. So what do we have is 3 multiply with 4, multiply with 3, multiply with 2, which is simply equal to 72 ways. Okay, so for the third one, 1, 2, 3, 4, and 5, how many 4-digit odd numbers greater than 3000? So 1, 2, 3, 4. So now I need to make sure I have odd number. So the odd number can either be 1, 3, and 5. So I should restrict the last digit to be 1, 3, and 5. Greater than 3000, so that means the first digit should either be 3, 4, or 5. Okay, so I have one problem over here because I'm supposed to use 3 and 5 for the first digit. So I should restrict the first digit to be either 3 or 5. But 3 or 5, I should restrict them at the end as well. So since I have two conditions with the same number, we should separate them into a few cases. Okay, so let me separate into case 1 where I start with 3 or 5. And then the second cases where I start with 4. Okay, so start with 3 or 5. So at first, I should start with 3 or 5. So that means I have two choices over here. Either 3 or 5 will be in front. So one of them will be in front. I'm left with another one from here. Plus with 1. So that means I have 1. And then either 3 or 5. So if 3 is in front, I'm going to have 5. If 5 is in front, I'm going to have 3. So that means I have two choices over here. Okay, so out of 5, one of them will be in front, one of them will be at the back. So I will be left with another 3. And then this one will be with 2. Therefore, I will have 2 times 3 times 2 times 2, which is simply equal to 24. And then now start with 4. So 1, 2, 3, 4. I definitely need to start with 4. So I only have one choice over here. I need to end with 1, 3, or 5. So I have 3 choices here. So out of 5, 4 has been chosen as the number in front. Out of 1, 3, and 5, one of them will be at the back. So if let's say I choose 5, I will be left with another 3. So this is 3 choices, 2 choices. Therefore, it will be 1 times 3 times 2 times 3, which is also equal to 18. So that means the total number is 24 plus with 18, which is simply equal to 42 ways.